This chart shows our historic energy consumption in the United States from 1750 to the present, from 0 to 100 quadrillion British thermal units. The lower section is our wood consumption, followed by our coal consumption, followed by our oil consumption, our natural gas consumption, our hydroelectric consumption, and our nuclear consumption. If we count all this carbon that's underneath the green line here, this is all carbon that we took out of the ground and put up into the air. This carbon got into the ground in the first place through our biosphere. The plants pull carbon out of the atmosphere, animals help process it through ingestion and excretion. We pulled it out of the ground and threw it up into the air above us. To undo this, we need to bring this carbon back into the ground.
Every animal has a role that it can play to help heal and maintain the land.
And when the plants are growing without a sustained animal interaction, they grow like this, so that the plants grow and then they get crowded and they die, and there are not animals that bring that material to deposit it on top of the crust. So it stands and it creates a sponge, which is a mixture of fire fuel and air, which creates the conditions for fire. And the successive waves of fire create desert. This here is a scale model of an equatorial cross-section of the Earth. The inner core, the outer core, the lower mantle, the upper mantle, the crust, and the atmosphere. There is the internal heat from inside the Earth that's radiating continuously in all directions at the inner portion of the crust, and then there is sunlight. The sun radiates on the Earth from the outside, but it only hits the Earth at less than half of the Earth's surface. When the solar radiation strikes the surface, it can raise temperature by heating the crust, or if it strikes plant material, the plant will use that solar radiation to take carbon from the air, combine it with hydrogen, release oxygen and water. In effect, what that does is it lowers temperature. So it uses solar radiation to produce chemical reaction and cooling. When we release carbon that was brought into the ground by our biosphere and we put it back into the air, where it goes is it goes into that very thin layer between that brown line, which is the surface of the crust, and that first pencil line, which is the tropopause. When we talk about global warming, we're talking primarily about the warming in that very small layer. Our historic biosphere pulled carbon out of the air, stored it in the ground, and produced cooling. We took that carbon out of the ground, put it back into the atmosphere, and produced heat. More growth will pull more carbon out of the atmosphere and produce more cooling.
Look how crooked. Look at this. Dead. There isn't as much as people shaking the trees here. So people plant trees next to that. If you plant a tree and don't take care of it when it's young, it'll not become a big tree.
We need to go through with metal blades and get it started. So in the areas that are like this, and cut it up so that it creates the layer on the ground that can now retain water.
Here is the same site about a year and a half after the treatment, and new vegetation is growing up, which could be nutritious for wildlife, which could digest it and bring it down to the ground, creating more topsoil and building up the soil. Beforehand, there was a canopy that was here. You really couldn't see past right here. There is a nice forest floor with a whole bunch of standing trees, and this actually looks more like a forest. But that's what it looked like before. The land itself needs to be fixed and healed. That's sickness. That is sickness of land. We need to get in and start fixing. the right way to do it is to get in cooperation with the leadership of the town and to do it.